Hello everybody, welcome back. We are doing the second lesson here in combinatorics. Now, the first video we focused on multiplication and addition law. This one kind of does take a slight detour away from that, and then we're kind of going to connect both the ideas from the first video and the second video. We'll kind of come in maybe video 4 or 5 around about there, and we'll kind of recap some of those skills when we get to that point. So really just setting some strong foundational knowledge for the topic. One of the most important pieces of foundational knowledge is factorial notation. If you haven't seen this before, exclamation marks are actually a part of maths. They mean something. So the very first question looks at finding the answer to 5 exclamation mark, which we call 5 factorial. Now, what this simply means, for any factorial notation, first rule is they have to be integer values, positive integer values. They have to be whole numbers, okay? How my factorial notation works, positive whole numbers I should say, is 5 factorial is simply 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Hopefully we can see the pattern here. Any number with an exclamation mark starts with that number that just decreases by 1 all the way down till we hit, we don't actually hit 0. If I multiply by 0 here, the whole thing disappears, right? So we go all the way down until we reach the number 1. So if I do that, I've got 5 times 4, that is going to be 20. 20 times 3 is going to give 60. 60 times 2 is going to give an answer of 120. And you can imagine now, if we have 6 factorial, well, we times the whole thing by 6, and these numbers get really, really large really, really quickly. So the second example looks at a very similar idea, but now I've got 10 factorial. Well, we just saw 5 factorial is 120. If I do 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, that is going to be a gigantic number. So we don't want to just get the raw numbers all the time. We need to have some algebraic tricks to how we can simplify, rearrange, and kind of tidy up what we have. So let's come here and we'll zoom in a little bit so I have a bit more space. I've got 10 factorial equals 3 factorial multiplied by 8 factorial. Well, if I follow this out, one of the core ideas from this topic is I can rewrite something like 10 factorial as 10 multiplied by 9. Actually, let's write the whole thing out, because I think this highlights the idea a little bit easier. Times 8, times 7, times 6, times 5, times 4, times 3, times 2, times 1. So I ran out of space, so I had to resize that. So if I write out the full list here, okay, and now that I've got 10 factorial written out, I want us to consider 8 factorial. Notice that is one of the numbers on my denominator. Well, 8 factorial is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And if I just use my highlighter here, we can see that this line of maths is the same as this line of maths here. So one thing that I noticed about my factorial notation is I don't have to write out the full sequence. I'm actually going to rewrite my line at the top here, this 10 times 9 times. We're going to rewrite this 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I'm going to rewrite that as simply 8 factorial. So I've shortened my entire line of mathematics. Okay, I'm going to get rid of this on the bottom here too. So now if I consider what's on my denominator I have 3 factorial multiplied by 8 factorial. And now hopefully we can see that this term here is matching this term here, and the two things can cancel out and be equal to 1. So I've simplified my maths immediately. I don't need to find 10 factorial. I can simply try to match my denominator, get some nice cancelling, and then I can re-evaluate what I have. So if I look at this, I'm not finding 10 factorial anymore. I'm simply doing 10 multiplied by 9 divided by 3 factorial, which is 3 times 2 times 1. Well, 10 times 9 is going to give 90. 3 times 2 is going to give 6. I've got 90 divided by 6, which will give an answer of 15. So we have two main skills here for our factorial notation, okay? We can find the value of any factorial by simply just doing, for 5 factorial, we can do 5 times 4 times 3 times 2 times 1. And for the fraction ones, we want to match our denominator, cancel down, and normally that creates a much nicer, much smaller number for our final answer. Hopefully you guys found that helpful. Any questions, feel free to comment that down below, and I'll see you guys in the next one.